Hello students of PSC 5032. Your assignment concerning the VA study using mindfulness as an intervention to reduce severity of PTSD symptoms is coming due. I wanted to go over all of the parts, things that you need to discuss in your article in order to have a good evaluation. The very first things that I already had produced a short video regarding are the hypothesis and the null hypothesis. The hypothesis of this meta-analysis is that the severity of PTSD symptoms will be reduced by an intervention utilizing guided mindful meditation. Now, that's a very general hypothesis, and as just stated, it is untestable. In order to make a hypothesis testable, it has to be concretized or operationalized. So an operationalized form, a testable form of this hypothesis might be something like this. Guided mindful meditation as defined by the individual sites and described in this paper will reduce the severity of PTSD symptoms in a group of veterans as measured by inventories that were utilized at each of the studies, each of the sites. So there you have a more concrete, testable version of the hypothesis. The null hypothesis is simply that whatever your intervention is, it does not work. The null hypothesis in this case would be guided mindful meditation makes no difference in treating veterans for severity of PTSD symptoms. The null hypothesis is a construct. It is utilized. You won't find it written in the study, usually. The null hypothesis is a statistical construct that is used to statistically analyze whether or not the results of the study have significance. Why do we use a null hypothesis? Well, frankly, it's easier to prove something wrong than it is to prove something right. To prove something wrong, all you have to do is find some instances wherein your construct is not true. So you get into an area that seems to be using double negatives. For example, researchers want to reject the null hypothesis. In rejecting the null hypothesis, which is, of course, that guided mindful meditation does not work, rejecting the null hypothesis means that the alternative hypothesis, or as it's also called, the research hypothesis, is accepted at whatever level of significance they've chosen. So you get into a situation where you're actually expressing yourself in double negatives, and I think that's kind of strange, but it is something that you need to be aware of. Researchers want to reject the null hypothesis. So there's a little poem that has to do with Valentine's Day. Roses are red, violets are blue. If you were a null hypothesis, I would not reject you. Okay, enough of that. If you reject a true null hypothesis, then you have committed a type 1 error. If you accept a false null hypothesis, then you have committed a type 2 error. Okay, so researchers want to reject the hypothesis so that it validates the intervention that they have performed. You need to have a hypothesis that is testable, meaning that it's concretized and in ways that yield numerical data, is the most scientifically clean way to perform a statistical analysis. There are other kinds of data. You may have heard of the acronym NOIR, the French word for gray or dark or black. NOIR refers to nominal, ordinal, interval, and ratio data. Nominal and ordinal data are discrete categorical data that can be used in statistical analysis, but the kind of analysis that you use are limited because of the nature of that data. Nominal data might be something like gender, eye color, type of fruit, for instance, or that would be nominal. Ordinal data is simply who came in first, second, third, and fourth. The weakness of ordinal data is there is no standardized unit between first and second. The distance between first and second could be a split second, and the distance between a third and fourth could be a minute. So that's a weakness with ordinal data. The other two kinds of data are interval and ratio. Basically, they are interchangeable. Interval and ratio data can be sliced and diced. They are numerical in nature. The only difference between interval and ratio is ratio has a true zero. Examples of ratio data would be weight or height. There is a true zero there. Interval data goes below zero all the way to infinity, and above zero all the way to infinity. But both interval and ratio data are numerical data, and they are the cleanest and easiest to use in statistical analysis. Okay, so we have some data that is numerical from the inventories that were used pre and post. We also have some data that is not quite as quantitative, and that's the result of clinical interview. So the kind of statistical procedures that can be used with the quantitative data are different from those that can be used with the more qualitative interview data. Okay, testable hypothesis, gotta have it. Null hypothesis simply states that whatever your intervention is doesn't work. The null hypothesis is a construct utilized for statistical analysis. You aren't going to find it written in your article, but I want you to specifically spell out the null hypothesis. You should be aware of what it is. Researchers want to reject the null hypothesis so that it affirms the intervention that they have performed. The sample in this case was generated by a series of surveys. I believe there were 150 sites surveyed, and of those 153 sites that were surveyed, 7 studies at 6 sites were chosen because they had a comparison between the intervention group and what is known as the treatment as usual group. So the treatment as usual group is the control group. Those who receive the intervention, that is the experimental group, so to speak. And what you're doing is looking at the differences between the pre and post scores of the intervention group versus the differences of the pre and post scores in the treatment as usual group. The best way to measure those differences in a meta-analysis is to look at the mean of the pre-tests versus the mean of the post-tests, look at the difference, and then divide it by the standard deviation. If the standard deviation of the pre-test scores is different from the standard deviation of the post-test scores, you average the two standard deviations. You divide the difference between the pre- and post-test scores in the control group versus the pre- and post-test scores in the intervention group by the standard deviation. It's commonly called Cohen's d. It's referred to as effect size and is the statistical weapon of choice, so to speak, in this kind of a study, a meta-analysis. The sample has difficulties. It's a rather homogeneous group of veterans, mostly all male. And of course, the nature of the sample it determines what population you can generalize the results to. You need to state precisely what population can the results of this study be generalized to. The best way to get a sample is, of course, random selection. This study does not have random selection. The veterans check themselves in for treatment, and there was no randomization in assignment to intervention or treatment as usual. In one study, the veterans self-selected. Self-selection prejudices the participants towards reporting favorable results and is considered a confound. There are many confounds in this article, and discuss as many of them as you can identify. This is a between subjects study because you have a group in the intervention treatment group, and that is compared to the pre and post scores of a treatment as usual group. The difficulty with a between subject study is that individual differences can confound the results because you have different set of people in one group versus the other group. In a between subjects group, individual differences are amplified. Versus another possibility not done in this study is a within subjects group where each individual is compared against his own pretest. So a pretest is done on a group, all of the people in the group. A post-test is done on all of the people of the group after the intervention. Basically, the package of personality traits that is brought to the pretest is the same as the package of personality traits that is brought to the post-test. So you have less of a concern with individual differences. However, you do have time confounds or history confounds. Something could happen in between pre and post to some of those individuals that would change them so they aren't quite the same person as they were when they did the pretest. Sickness, maturation, those kind of things. Between subjects, individual differences are amplified. This study is between subjects. Within subjects, individual differences are downplayed. However, history or time confounds are amplified. Okay, so look at the conclusions of the study and determine in an informed scrutiny of what they've said, an informed scrutiny, not just an opinion. Your opinion has to be based on some information about the utility of this study. And then there's an opportunity for you as well to give your own impressions based upon your own individual experience. It does not quite have to be so informed by a knowledge of research methods. Okay. Estimate the utility of this study for use in veterans programs. Be sure and include all of the things that I've mentioned here in your study. Use APA format. That means a cover sheet and APA format throughout with a reference page. Your references, of course, could be whatever text you're using and also the study itself. That's about it. I look forward to looking at your work, and I hope this answers some of your questions about what I'm looking for in this final critique. So good luck with it, and I look forward to looking at each of your papers. I feel a bit like Indiana Jones in that scene from one of the movies where the students were crowding up against his door, and he goes out the back window and runs. Okay, I'm not going to go out the back window and run. Thank you for your patience and getting feedback to you.